Because I'm muted. Let's unmute myself. Testing, 1, 2, 3. Sorry, I haven't used this program in fucking forever. Because I'm muted. Let's unmute myself. Testing, 1, 2, 3. All right. Sorry, I have to use this program in forever. I'm muted. Let's unmute myself. Testing. There we go. All right, sorry about that, folks. So we had some technical difficulties there with Streamlabs. I had to fire up the stream with Restream. Thanks for being patient. I tried to give out some pocket change. Apologize about all the technical difficulties. Cliff and I got in here and we were ready to go. And then Streamlabs, as y'all see, I tried to stream like 3 or 4 times. I've never had that particular problem before. Just wasn't transmitting. All right, so thank you guys. Appreciate your patience. No big deal. Cliff and I are going over some stuff today that we know, we've talked about before, and we just want to get you guys knowing what's going on. So overall, Cliff and I meet twice a week. We meet on Mondays and Wednesday, both times at 1 o'clock p.m. Eastern. Lena had mentioned earlier that she felt bad about missing yesterday. There's no big deal, but do go ahead and look at the Discord under community. There's a channel called Darwin's Law. There you will find a Word doc for the Avita Ed introduction. Hopefully by next Tuesday you can complete that. Just change the name so that it says Lena _ Avita Ed introduction _ D Law. Basically, you're just renaming the document so that I know it's from you. You email that to me, pocketlocker86@gmail. The number 1 instruction is change the font color. I recommend using blue. That way it's easier for me to see what you wrote. I'll go over those, and then if I get that by next Tuesday, I will send you the password and link to the classroom that we'll be using as we go through the rest of the Avita Ed exercises, with the goal that hopefully you guys will follow right along with my class and end up doing some community independent research projects in Avita Ed. I also think it's going to hopefully radically transform your approach even to counter-apologetics, because so much of what we deal with will be touching on the philosophy of science, and we'll also start Rob Pennock's book today, and so we'll be talking a lot about intelligent design creationism and why it is not science. But let's switch over and talk about what Cliff and I are doing. I think Cliff and I are going to be talking about hopefully a project that I think, at least for now, we'll be using MABE to start with. We've kind of changed directions a bunch of times, mostly because of me and shifts in sort of my stack of priorities. But I think recently we've decided it's probably best if we get back to trying to publish something. We've certainly got a system that kind of works out of the box, MABE, modular agent-based evolver. And I think we're going to use that to do some sexual selection research. And so I think we'll get into this thing called shape mating. And sort of running in parallel to that, I'll be working on my coding skills in C++, Python, and Rust. And as I start to build brains in C++, Cliff will be, doing code reviews with me and helping me get better at coding the systems that I need to actually do my experiments going forward. But, we're also just going to try to get some stuff done with the tools we already have. So today, I think we're going to talk about the shape mating project. This is really Cliff's idea. I'm happy to say that I think I'm part of the reason that I got Cliff excited about sexual selection research. But as one would expect, Cliff's come up with some super cool ideas. This shape mating thing is one of them. We've started messing around with it and getting some preliminary data. So I want to talk about that system overall so you guys know what's going on. And then over the next week or so, you'll see me coding this system and trying to get some at least preliminary results to bring to Cliff next week to see if what we've got so far holds up when we run things at the proper replication size. So Cliff, I'm gonna turn it over to you. Can you talk to us about just this whole shape mating idea, like what it is, where it comes from, why on earth you think this thing is cool, and what we do with it? Because believe it or not, it is pretty cool, and we've gotten some interesting results. But when you first started mentioning it, I was like, what are you talking about, Cliff? But it works, it makes sense, so tell us about it.
All right, so the idea is you have in most species, you've got generally have two mating types, right? We can think of them as male, female, but it doesn't have to be. And the critical thing here is that they're different in some fundamental and genetically determined way, and those differences increase the likelihood of successful mating. In the case of mammals, you have both body plan changes in terms of organs, specifically sex organs, but also in terms of the way that the actual like egg and sperm like evolve and interact. Like we're now so locked into, both the sex organs for delivery, and the actual sex cells and how implantation in the egg works, that we can't, like, you can't even really see a way to get out of it. You're kind of trapped in it. And so on some other work, I had done some stuff trying to ask basically about what happens in cases when you introduce sexual crossover and different ways to either have random mating or to have mating with selection. And on rare occasions, you would see something develop that looked like sexual selection and looked like mating types, but it was unstable. But the system that we built was very simple, and there was no way to sort of lock in the sex types, because it just wasn't in the physics of the model that I was using. And so I got this idea. I said, well, what happens if we introduce something sort of like sex organs, and we do a very simple conceptual model where it would be non-advantageous if two individuals had the same type of sex organs, but if you have different types, and the more different they are, the more beneficial it is. So the idea is you kind of want a system where on its own it wouldn't develop, but under certain conditions it would. And then the idea is, once it would, is it beneficial enough that it becomes stable? And that if the original condition that caused the populations to evolve to have these different mating types, if you remove the initial pressure, would the mating type stay? Right? And this would be interesting because it would give us an explanation, a possible explanation for how mating types could develop. But it would also tell us that you can't expect to look at a currently existing sexually reproducing species with certain mating types and assume that something in their current environment is going to inform us as to how those mating types came about. It may have been something in ancient history, some condition that is long gone, that resulted in the formation of mating types, and then they get locked in. And so that's kind of the hypothesis here.
Yeah.
So
Give me a
we're building
Cliff,
a toy model to test this hypothesis.
Can you hear me?
Yeah.
Keep going. I got to grab something from my room. I forgot. Just go ahead. I just want you to know I can still hear you.
So I mean, well, that's all I got. But yeah, I guess what else I got? I got nothing. That was the end of my story. You mute yourself there, Jay. Oh, you're not even there. Never mind. Now it's gonna look weird. There he is. Now he's back.
All right, so
I ran out of things to say.
It's okay. So the thing that's really cool about this is we talk a lot about the evolution of complexity, right, and complex features. And one of the things that is important to think about is that you have all these intermediate stages, right? And so these intermediate stages might be beneficial in ways that are not expected. And sort of what we're thinking here is this is a slightly different way to think about the origin of complex features and complex behavior, in the sense that you just have this selection pressure. It just goes away, but now you have this sort of ecology built in, right? Now it's too late. You're trapped in the sexual system. And so while you may think that that pressure is maintaining the sex types, it doesn't have to be anymore. It's now just the fact that, like Cliff said, we're locked in. I can't reproduce without a female. So even if it would be beneficial for me to, say, revert to asexuality, right, I just can't. And that's kind of what we're looking at here, and it's super cool. So let's talk a little bit about how you conceive of the shape function, right? Because you have this visualization of concave versus convex versus you're sliding past each other. And let's talk about a little bit about how that actually, because we're going to be representing all these things in a computer with numbers. There aren't going to be any peni or vaginas or, you know, hardcore sex organs. So when we, what do we help us do the concave hand thingy, Cliff, to help them understand these numbers?
Well, does this thing have a whiteboard on it?
It should. Where are we at? Are we in the, I don't know if we got a whiteboard. Yeah, do you have an office? We've got whiteboards. I don't think we've got one in the office, but we could just step outside the virtual evolution lab and we'll have a whiteboard. So let's go do that.
Follow you.
Yeah, yeah. Actually, wait, let's go back. I got a better idea. So I realized that's an improvement I need to make because I didn't put, they didn't put whiteboards in these offices, but they'd be better if they did. So they should allow us to, for some odd reason, there's always, there it goes. You know what it is, Cliff? They just updated this. So they just updated it today. There's a brand new version. All right, here we go. All right, so where do you want your whiteboard, Cliff?
I don't care.
Let's put it over here. All right, so now you've got a whiteboard over here. Boom, done. Who cares? Why would we move? We could just add one to your office.
Here we go.
There we go.
World.
Boom.
All right, wait, no URL.
No URL found on objects.
What?
What is that type of nonsense? What is happening?
What is happening?
What's going on? We don't like this.
Oh, man.
All right.
Do this the old-fashioned way.
We'll do it the old-fashioned way. You're going to have to pull up your PowerPoint and share your screen.
Yeah.
And then draw on your little PowerPoint slide. But go ahead, share your screen, and we'll do it the old-fashioned way. And then I'll get this worked out since I'm officially the Gather representative, so I take all the heat when they have technical difficulties.
That's damn straight you do. What am I showing? I'm just going to share screen 2, I guess.
Punked by Gather Town, exactly. I'm trying to be all fancy, show how flexible they are, and they're like, nah, Jay, we're going to make you look dumb right now.
All right, here we go. Let's zoom
also, I'm such a goddamn stoner, I can't find a fucking lighter. Oh, my Lord. All right, go ahead, Cliff.
What we got here? All right, there we go. All right, so the idea is we start out and we say everybody's a square.
Boom.
And we're going to kind of imagine that our little square organisms live in some kind of, maybe like a tidal pool.
All right, Cliff, I'm listening. Don't forget. I'm turning my speakers on so I can listen to you while I go find this thing.
So there's some current in the water here, and these things are floating around. Oh, that's a bad one. And these things are floating around in the water. Now, if two of them get next to each other like this, and they stay like this long enough, then they're going to produce a little baby. There we go. And the thing is that there's some water current, and it's moving them around. And so the likelihood, if two of these things want to mate, if they get close to each other, the likelihood that they don't get blown apart by the current is relatively low. Now, if they could evolve so that there was one type that looked like this, and there was another type. Let me draw that bigger. There's one type that looked like this, and there was another type that looked like this. Well, then the currents in the water wouldn't push them apart so much, and they're going to have a higher chance of success. The problem is, if one of these circle guys, let's say, tries to mate with another one of these circle guys, well, they're going to have very little surface contact. So here they're going to have really good surface contact. Here they actually have good surface contact here. They just can't keep it together. But here they have very little surface contact. Likewise, if two of these convex guys would get together, we got like one like this and one like this. Well, this would also be terrible because there's very little surface contact. There's just these 2 points here and here. And so these are going to fail to mate also. So the idea is you want to get it so half your population is these circles and half the population are these little stars, and the circles select for the stars and the stars select for the circles. And that way you get better reproductive outcomes. So the question is, how do you get the system? Well, first of all, how do we model that? How do we model the fitness function such that this gives us an okay fitness, but this double circle or this double star gives us low fitness, and this circle plus star gives us very high fitness? And then how do we integrate this into the system? So that's what we're talking about.
Absolutely. And what I'm looking for is we did some tests, right? And I'm trying to find those heat maps that we generated. Oh, don't you have a thing that can generate that super fast?
That I'll have to go look it up. I have it in a Python script somewhere.
Yeah. I want to show them that those Python scripts.
It might take me a minute.
Yeah. I'm trying to find mine. That's what I'm over here looking for. Just because it'd be nice to show them what we got.
Well, it'd be nice to show me too, because I don't remember what the hell we were. This was like 4 months ago.
Yeah. Exactly. All right. Let's see. So what we're trying to show you is that this function creates basically a heat map where, and this is what Cliff is talking about in terms of the selection pressure, is trying to figure out what function to use. Like, in other words, how strong should this pressure be? So we know that basically you can represent it as we use their shapes between -1 and 1, right? And you can think about it as 0 means you're square. 1 means you're perfectly concave, and -1 means you're perfectly convex, or vice versa. And then there's a function that Cliff actually wrote, right? Because we described this whole thing, and I was like, yeah, this sounds awesome, but how to make the formula, I have no idea. So Cliff just wrote the formula, which is maybe why I can't find it, because I'm looking in my MAVE stuff, and it might actually be...
You must have it implemented in your...
It might be in my Python stuff. Yeah. What it is, Cliff, is I did all that stuff on my streaming computer, and I've had to switch machines, and I don't know what I switched over and what I didn't. But yeah, let's show this, and then I'll show them when I work on it and do the color mapping, and I'll show the fancy stuff and break it down again. So this is fine.
There we go. So yeah, this is the function.
Thanks,
so
and also you Cliff, I was just gonna say you won the race, so come through the channel later. I'll give you some pocket change.
Oh, whatever.
I'm just fucking with you. Go ahead.
So they don't have sex organs; they have sex bodies.
Sex bodies. I needed that. I didn't know what to say. They have sex bodies. Your body shape determines.
Is sexual. Their whole body is involved in the sex act.
There we go.
So, and you don't want to be a square. Like, squares are boring.
Yeah, you don't want to be a square. Like YouTube Punk said, I'm no square, buddy.
Yeah, you want those curves. You got to have curves. Convex curves, concave, either one's real sexy. No curves, it's just not attractive.
Yeah.
So So what this function says is if both types are 0, then they get this middling, this 0.5 success rate. That's right here in the middle. If one of them is a 1 and the other one's a -1, they're going to have this high. It's going to be this highly
the perfect
beneficial
mating. They're always going to mate. Like if they get together, they're mating every single time and reproducing successfully. Right.
And if you get 2 -1s together or 2 1s together, then they go to 0.
They never. It's the worst. It's the worst. They're bumping the same parts together, and it just absolutely they got no surface contact.
So I kind of want to modify this function a little bit.
No
so
adhesion.
The areas right here actually go downhill a little bit, or don't go up quite so easily, so that you kind of have to neutrally drift across here. You don't get an advantage here yet.
So you're trying to kind of make it more of a complex function.
Yeah, the problem is like right now, you in the test that you ran, even before we introduced the switch cost and the food stuff,
right?
You are already getting the mating types, and I think the reason is because this is such a there's such a gradient, there's such a strong gradient here that evolution can find the gradient, and so I think we have to hide the gradient from them a bit.
Okay.
And it may even
so
be
that it's not so obvious, right? Like you're just saying it was so discreet that they just quickly figured out that they have to just become 2 separate types, and then they were hard separate 2 separate types. So we've probably got to keep those results there to show that, but then we've got to immediately be able to say, and that was just too easy for them, and so we had to do something else.
Well, and we'll run it with different functions.
Sure, okay.
We'll say, look, here's a function. If you use this, then you get it. You don't have to do anything. But here's a function. If you make this function harder, well then this is then you got to jump through these extra hoops.
And this is kind of what I wanted to touch on. I was hoping I could find the pictures, but I don't want to waste too much time on it. But I'll show them when I do. Also, it's nice when you kind of have this sort of heat map representation. Was that when we changed that one parameter in the function, which was essentially the power that the one term was multiplied by. Oh, right. You got these immediate huge differences in the map. So can we explain those quickly just to show them what's kind of going on there? Because I think that's...
I don't remember the exact, what's going on.
It's just whether we were multiplying the function by 1, 2, or 3. Like it was the power, right? And it was just that. Okay. And that created whether or not essentially only the corners. It basically determined how valid the middle was. Right. You see in this one, like there's this wide swath where you've got, almost perfect.
Basically anywhere along the diagonal is the highest fitness.
Right.
So your 0, 0 is as good as 1, 1. Sorry, -1.
Yes.
In this case. Is as good as 1, whatever. It's -1, -1, or 1, 1. Actually, this function is backwards because it's the axis here is 1 to -1. And
yeah. We flipped one. Yeah.
So here, this axis is flipped. That's why I was confused.
Oh, okay. I see. Yeah. No worries. I had the same thing in my code when I first did it, yeah. And I flipped one of the axes too, just to make it like we imagined it in our head. Yeah. But so basically I'll show you guys that. But you can simply and it's just one example. Cliff is talking about a different way. Basically, by changing the formula that we use to determine this fitness function, basically again, all we're doing is determining, the adhesion formula, right? How their shapes relate to each other. But that simple change really determines how strongly this effect happens. Now, here's what's crazy about this. The first crazy thing is exactly what Cliff said, is that this fundamental thing where what we do is we introduce, I guess we should talk about the food cost in the food, right? And a little bit about Berry World, which is perfect because that is the first thing I'll be coding up, even though I don't need to for this. But we could talk a little about Berry World and the switch cost because that gets at this question of what you're saying about. All right, so these are agents. They've got little brains, and what they're trying to do to get into the mating pool to sort of prove that they're worthy of reproducing and demonstrating their high fitness is they've got to sort of solve this puzzle that we put in front of them, and we call that puzzle Berry World. And basically, you can think of it as a grid. every space in the grid has a berry on it, either a red, a blue, or a green berry. The green berries are positive. They give you a fitness boost. The blue berries are neutral. You can eat as many as you want, but they just don't do anything. And then the red ones are toxic, right? They actually are costly. And so what happens is we can also introduce. Actually, do you want? Or should we just go with they're all positive, but there's just a cost for changing, or should I just stick with what I was going?
I mean, we can go however we want, but that's the model. So the model is, anytime you eat any food, you get a benefit, but every time you switch from one to the other.
Yeah. I always like to do this thing because of the sexual selection on toxic traits, which is a separate question. So let's just say all the foods, the blue food, the red food, and the green food, they all give you a benefit. But like Cliff said, we introduced this thing called the switch cost, which means, like, let's say the benefit of eating a berry is 1, the switch cost might be half, or the switch cost might be 1.5, right? And then depending on that switch cost determines, how often they will switch. And so what Cliff is really getting at here is we can use that switch cost ideally to make it so that what type of berry you eat will likely sort with what shape you are. Because the other shape will be selecting for us, right? And so what's interesting about this is so far, we haven't had to do that, right? We didn't have to do anything with the berries, and we didn't have to even introduce a switch cost. And just with Cliff's shape function alone, they're sorting based on the shape type, right? And so what's really interesting is, again, we're going to play with this function of how quickly and easily do they sort. And hopefully, again, it's really cool that it works so cleanly, but if that continues to hold up, we're going to look to do something more interesting. And hopefully we find something more interesting where berry world becomes at play, right? Where this issue of there's almost like an evolutionary tension, right? Because there's one selection to be the right color based on what your diet is, and then there's this other situation you've got to deal with, which is your sexual shape, right? Is that
right? Well, I mean, the idea is that the way the model would be built, you really want to mate with someone who's the right shape. If you're round, you want to mate with someone who's who's convex, or sorry, concave. If you're convex, you want to mate with someone concave. If you're concave, you want to mate with someone convex. But the agents, they can't detect that. When they go to select mates, they can't see the shape of the
Right.
other individual. What they can see is the color, and the color is determined by the food they eat. So if they're running around and eating red food, and the preference for red food is associated with being convex, then if you're concave, you should evolve to have a preference for red individuals, even though there's no direct link between eating red food and being concave. There'll be a genetic link between those two things. And so even if we don't do the switch cost, if we just do berry world and say you can eat whatever food you want, the food determines your color. The color is available for selection. And now we say, do they use the color as a secondary sexual trait, which is determined by behavior, to signal their shape to increase their fecundity?
Right.
And even if we don't do the switch cost, but we can still show that there's an association, that's a secondary sexual trait. And that's pretty cool itself.
Right. And it's totally de novo. It wasn't in the system when we found it. These were not male and female mice from the beginning. They literally became that way organic. Go ahead.
Yeah, no, what would also be really cool is that the color is determined by a behavior. The behavior is determined by genetics, but the color is determined by behavior. So we'd be saying this is a behaviorally determined, it's the behavior is genetically determined, but the trait is behaviorally determined.
Right.
Right. And so we're talking about a complex trait here.
Right.
Like, this is necessarily a complex trait. And so I think certainly A life will eat it up.
Complex trait, simple system.
Yeah, yeah, yeah.
And then what gets crazy is some of you guys we got into this coercive mating stuff, and I mostly say that I always tell people we got into that because we got in a fight and lost. But it's kind of interesting because we started poking around with that stuff, right, just to see if we could figure out what coercive mating would look like in a digital system, because it's not something you think about every day. And it turns out it was pretty simple to conceptualize, right, because we build our systems a lot of times with sort of tournament selection, right? Which is the idea that you can think of this as two random individuals getting picked, and then us just keeping the winner for so many rounds. And if you win a tournament, then you go into the mating chamber, and then you get to pick a mate based on your preference. That's what Cliff is talking about. So you'll get to say, oh, I'm looking for red people, or I'm looking for green or blue people, right? And so then it was sort of like procedurally clear, like, oh, coercive mating is when we call that system elect, right? Let's say you're the mom, you get into the lec, and then we say the lec size is 8. Well, then you get to go through evaluating 8 dads, and then you choose based on your preference which dad you'd like to mate with, right? Well, then coercive mating's pretty simple. A dad shows up in the lec, and then he becomes the dad. He doesn't care if you like him, if you prefer him, or if you evaluate him. He just short circuits your entire preference process and literally forces himself to be, the dad that you have to reproduce with, right? And this actually has all of the features you would expect in an animal system with coercive mating, right? It undermines the female's choice, and at the same time, it undermines the sort of fitness competition amongst the other potential dads. And so what was so crazy was, without even really introducing all the food stuff and modeling anything with the food, the switch cost or anything like that, we started to see that basically the coercive type of behavior that we coded for, as well as the counter to that behavior, because we coded the potential that you could evolve the ability to resist the coercion, right? They immediately started to sort with the shapes, right? So it was almost immediately like the same way you were de novo evolving, male and female sort of shapes, right? The mating types. You were also getting this, again, complex, weirdly weird behavior like coercion to also immediately sort of very clearly also segregate into the same two types. It was almost like you were immediately evolving males who were much more likely to be coercive and females who were much more likely to be successful at resistance, right? All of this in these little digital organisms. So,
well, there's another question, which is if there are, let's say that the majority of males are coercive, and there are some courting males, and then there are some females that are resistant, and there are other ones who are not. You can ask the question, are the females who are not resistant
doing better.
Should we classify them as not resistant, or should we classify them as passively selecting for the coercive males?
Yes, this is like the collusion thing too, right? This is a bit,
Right.
This hints at the collusion thing, right? And it doesn't have to be an either or, right?
Yeah.
It's sort of like what we talk about with the counter-apologetic stuff, where we like strategically cooperate with certain people on the other side because you just kind of have to at some point, and that might get those females further than the ones who are completely unwilling to, right? So it's all kind of a very interesting thing. So, and we don't have to go too far down that rabbit hole, but I wanted to just show that for us it's really exciting because you start with this very simple question, this very simple system. They're digital organisms. They basically reproduce. There's a little grid with berries on it. They run around it eating them. They get a color score based on what their diet is, and then based on that score they look to find a mate, right? And then they have a shape, which is just determined by essentially a number, and that then gives us, like most experimental evolutionary biologists hope to find, a system that you can use, that you can learn and you can pull apart and then use it to answer a breadth of questions, right? And what you guys see already is that we've got all these, things, and we're already having to pare down and focus. What are we going to start with, and then what's next? And that's why we said, what the fuck is shape mating? Because we're going to start with the very basic shape thing, and let's just do shape, right? And then we're going to layer on diet and berries and switch cost and all of that stuff, right? And then potentially maybe layer on some more complex stuff down the road. But yeah, I wanted to use this sort of first stream to lay out that roadmap a bit. We'll probably normally plan to go from 1 to 2 for these things. I know we were late today. We had some real technical issues. I do want to thank Cliff for, getting with me today. But I also don't want to keep him over our planned time. But Cliff, Wednesdays are more open for me, right? Because Monday I have to meet with Mike at 2. My Wednesday afternoons are a little bit more open. But so if you ever need to go over or meet about a bunch of other stuff, that's fine. I think today, though, we pretty much covered what we wanted to, right? They'll see me coding and working on this for today. I think we did get done what we planned to get done. And so I always like to let my co-host or whoever take the floor. And if there's anything you want to either mention, talk about, or share with me, this is the time to do that. And if not, then please just plug your stuff. Let people know anything else you've got going on and where they can find you.
All I got is that thing on Thursday night. I don't know where on campus that guy from Cal Berkeley who's going to be talking.
Oh, tell them what's happening, maybe, and then since Monday is our sort of more relaxed day, then we'll follow up and discuss that experience on Monday.
Sure. There's just going to be some creationist guy. He's a mathematician philosopher from Cal Berkeley. Who got invited by a Christian, evangelist group. To speak, and he's going to be. I've watched a couple of his YouTube videos, and I think what he's going to do is argue the improbability of Darwinian style evolution, and it's just like it's going to be a bunch of false leads. I already know what it's going to be.
Right.
So
right.
I'm planning on doing that.
But what will be interesting too, if you can feel out too, Cliff, is a bit of the dynamic there. Because, one, I find it almost predatory the way these organizations use student groups. And so it'd be interesting to see if you even can get a whiff of whether or not they even have like any sort of legitimate local connection to the students here, or is this just one of those typical cases of there's some national organization that probably goes around the country and figures out what they got to do to get this, because essentially they just need the student groups because they can't get access to space, right? They're nobodies. They can't you can't just show up at a university and say, hey, I want to rent your auditorium. So what they've got to do is find some sort of connection, usually I think through probably just talking to students and reaching out to these groups and saying, hey, we want to do this event and we're Christians and you think it'd be great. And the students go along with it, not realizing that they're sort of pawns in this bigger scheme. And it's really terrible because if you think about who most students are, right, they're just like,
and I think that there have been some cases where the Christian group these guys say that they're going to come and do a thing, and then I think that happened. There was a conference a few years back, a little bit before COVID. They had like a 2-day conference. Because there's the LNCA line and all the Avita stuff comes out of MSU at MSU.
Right. Yeah. Yes.
Of a bunch, and I didn't go to that.
I didn't either, but Mike and them, a bunch of people
kind of wishes I did, but part of me feels like I would have just lost it.
Same.
My philosophy, my bullshit-o-meter for metaphysics. So philosophically speaking, I think metaphysics is garbage, and I think it's garbage because
can't do anything with it.
You can use it to do anything. I think it's great for hypothesis creation, but I think it's utter garbage in terms of actually getting to truth. It's useless. It's like I can make up any story I want, so it doesn't matter. But so anyway, like in that context, but I now, like, I kind of know that now, like I've internalized that, so I'm okay with that.
Right.
And so I'm a lot more okay hearing, complete bullshit from these guys that I would have been 4 or 5 years ago when I would have just been like rabid. So I'm probably going to keep my mouth shut, depending on what the guy says. There was an argument I heard, he didn't make it, but he was on a panel, and one of the guys said, there are this many possible genomes that could exist. And if you look through history and you estimate how many species, there are this many species. And so there are this many, we know of this many genomes that result in a viable organism. And the problem is, it's like, dude, first of all, that ratio would be if each species only had exactly one genome.
Right.
But within a species, there's going to be like millions and
it's just
billions
it's ridiculous. It's
just
awful.
in that species. So that's already wrong. But then beyond that, you're assuming that there will never be a different organism, right? You're saying basically there can't be an organism that's viable that hasn't already existed. And so, like, you don't know what that number on top is, even if your number on the bottom is correct for the possible number of genomes. Of course, it could be that, like, there's, it doesn't have to be ATCG. It could be some other combination that makes up DNA, or there could be some other way to have genetic information that's not in DNA. And so it's just like, dude, everything you're saying is stupid. Like,
I've literally gone off on people like Otangelo, literally because what they were saying was so wrong. I was embarrassed for them, and I was like genuinely trying to stop them from embarrassing themselves.
Yeah, I mean, the one example I would give is, like, if you tell me, if I say, what's the probability, how long is it going to take me to if I have 100 coins, and I'm like, I flip one coin at a time, I just randomly pick up a coin and I flip it, and you're like, how long is it going to take to, like, flip 4 heads? There's a certain amount of time. Like, it's not going to take very long to get 4 heads out of the whole 100 coins.
Right.
But if you say, yeah, those 4 heads have to be in the first 4 coins, like, I lay them out and I number them 1, 2, 3, 4, 5, and you say, how long is it before the first 4 are heads while all the rest are tails? And you're like, oh, well, I don't know, I might get to the heat death of the universe before I get to that. I don't know. It's going to take a really long time. And that's what they do. They say this is the exact way that this genome is. And they say, what's the probability that this genome gets to be exactly the way it is right now?
Which kind of proves the point of evolution, right? Because
but it doesn't need to be this genome. It just has to be any genome that has higher fitness.
Yeah. And also the fact that we got organisms without getting to the heat death of the universe means something non-random.
Well, they think it means that God had to do it.
Yeah, but you know what I mean, right? Something.
No, I know.
Because we think evolution is slow, but evolution, given the substrate, is actually fast as fuck, right?
He may turn around and say, just because we observe certain phenomena now doesn't mean that it's always been that way. And if he does that, then I throw up my hands, because there's no point in talking to that guy.
Right.
Because he's like, the answer is like, yeah, you could be right. It could totally be the fact that just because we see it now a certain way, it wasn't like that, 1,000 years, a million years ago, 100 million years ago. But why should I assume that? Like, I think that it's reasonable based on the fact that we haven't seen, in my whole life, I haven't seen stuff change. In the 2,000 to 5,000 years of written history, it doesn't appear that things have changed. When we look at the geological record, it looks like things are consistent. So why should I assume, just to make your model work, that it's not consistent?
Never mind that they're then gonna propose something with, like, they're all changing in unchanging God who's eternal in his nature, right? Like, they always want to do what they accuse you of doing. You want to get a universe from nothing, and so you're like, no, I don't really believe that. And then they do, and then they're
I don't want anything. I don't want anything.
Thanks.
What I do is I observe, and then I make predictions based on what I observe, and I see whether or not my predictions are right. And based on that, I make more predictions.
Yeah, Cameron.
I don't want anything. The difference is they want a 5,000-year-old Earth. They want evolution not to be true. They want their God to be proven. Sorry.
Yeah.
Doesn't work.
Cameron Bennett said you got to talk to Sal and Otangelo. I think he knows Sal. He knows who Sal Cordova is, right? Do you know Sal Cordova?
I could conceivably talk to Antangelo. I think Saul, I'd want to kill him after 5 minutes. I think I just want to strangle. Because the thing is, Antangelo, I think, is just very misguided. Saul, I do not believe that Saul knows what he knows without being dishonest. And what he does, the thing is that there are certain times people can say something that's so wrong. They say something, it takes them 5 seconds to utter it.
Right.
But now it's going to take you a half an hour to unwind what they just said. Like literally, it's like trying to get shit back in a horse. You don't want to engage with it. Say, okay, fine, let's engage with it.
Right.
I literally have to take you to like 9th grade science so we can discuss like the scientific method. And we have to go through this whole thing because what you said is so stupid.
Yes.
It's so backward. Like we have to do some remedial math. We got to do scientific theory. Let's talk about, Bayesian methodologies, like all this shit as to why we know. And let's throw in some philosophy too, because you're not willing to accept that.
Right.
Fine.
Right.
So now it's like 2 hours later, nobody's listening anymore. And you're not listening. And the thing is, it doesn't matter because as soon as I try to make the first point, you're going to rabbit trail to some other thing, and it's just like, well, then what the hell? What the hell's the point? Whatever I say, you're just going to switch to a different topic.
So I think,
you go to Sal and I've seen people try to argue, really technical stuff with him and dodging retroviruses. And he just goes, oh, zinc fingers. And so look, I've looked at a couple papers. I've skimmed a couple papers on zinc fingers. That's his big deal. And it's like I think I said to you the other day, they're massively complex and they're not a big deal.
Yeah, like massively complex and annoying. And
they're well understood, but it's like just super complex.
Cameron said, "Do you know that Sal speaks against DeVita?"
Well, of course he does. He has to. Oh, guys, the funny thing is that these guys, they're trying to play our game from the other side. I reviewed a paper that was so thinly veiled creationist garbage where they did a digital evolution system. And
really?
I can't because of disclosure, I can't say specific things about it.
Sure.
Because it's not published work. And
you said you had to review it. Yeah, that's typical.
I reviewed it. I wrote a scathing page. Like
you did.
It was more than a page. Where I just went through everything. And the thing was that they published a thing. They managed to get in a journal that is now like a defunct journal. Like 6 years ago, they published a thing, or 8 years ago.
Wow.
There was an entire paper that someone published refuting point by point their previous paper. So that saved me a lot of time because I just cited that. I was like, first, what this person says, but now beyond that. But the thing was like, they didn't address a single point that this person had made in the refutation. And I said in the review, in the response to the editor, and I said, please share this with the authors. You could share my name. If they have questions or they need help building a better model, I'm happy to work with them. I said, this is, in order to publish this, you need to go back to the drawing board. Everything about this is wrong. What they were proposing was, imagine if you have C++ code in memory of a computer. And now we're going to randomly alter the bits of memory, not randomly alter the C++ commands to some other command.
Right.
That would be sort of like a Vita.
Right.
No. We're going to randomly alter bits. And what they said is there are so few bit alterations that result in even executable code, let alone code that's not a syntax error, let alone code that will actually run, that it's impossible. And you're like, dudes, but the DNA isn't like that. DNA has synonymous and non-synonymous alterations. And most are synonymous. That means that the mutation causes no functional change. But if you start flipping bits, every bit in a computer, if it's where the code is in memory, every bit nukes it. It destroys it. There's no single bit alteration that's going to get you to another instruction. And so it's just like, guys, the model you're proposing is utter garbage. It's not a comparison.
Right.
But that's what they want to do. And then they make up bullshit statistics. So, I've seen what they do.
Stupid Hunter just said Sal set the mutation probability in Avita to 0.5 and said that means the mutation rate was 50,000 since the Avita critters didn't die. He claimed Avita was unrealistic, but 0.5 isn't 50,000. Oh my Lord.
I mean, that's probably a 0.5 per site.
It's 0.5. No, it's 0.5 out of the whole thing. So like, it's like because I literally just did this with my students today. Oh, actually, we're gonna do it in the next day or two, maybe even today. It's like you set it to 10%, right? And there's 50 sites, so you expect to see 5 mutations. So if you go to, wait, no, it's Avita. You're right. I'm thinking Avita Ed.
Yeah, no. So that's a per site.
Yeah, it's per site. You're right.
Yeah, but Avidians, for the most part, have maybe 200 sites, between 50 and 200 sites. So even if you
we started at 100.
Let's say at 200 sites, that would be 100 per individual, which, by the way, would be ridiculous.
It's crazy.
But
it's crazy.
If you take the initial Avidian,
guys, the default is like 0.007 or something.
Was he using? Like, I could design an Avidian that you can hit with any number of mutations, and you're still going to have replicators. Why? If I use the replicator command rather than the replication loop, and the only mutation I allow is a mutation to a NOP-A, then either it's going to be lethal or it's going to do nothing.
Right.
And since half of the organisms, their copy command isn't going to get hit, 50% of them will be fine. And yep, they won't go extinct. So yes, I guarantee you I can build an Avidian case where a 0.5 mutation rate will kill it. They'll get mutational meltdown.
Yeah.
But I also could guarantee you I could build one where 0.5 will be fine.
Yeah. Totally.
That's I'd have to see the paper.
And literally, it's so funny because in our class we have students do group projects, right? They do independent experiments, right? And this basic sort of math is something that gets so almost trite because everybody does mutation rate, right? It's one of the easiest things to manipulate. It's Avita Ed. There isn't a ton of things they can manipulate, so they'll go for mutation rate. And they find this, right? If it's too low, you just don't get anything. But immediately if it's too high, and they realize why it's 2%, right? It's 2% because if you go much higher than that, you're going to hit the copy loop almost every time, and then it's dumb. And if you go too low, it's just going to be slow as shit. You're not going to get mutations fast enough to see anything interesting happen without, super long run times, right? So it's kind of cool because they all end up sort of trying to deconstruct the mutation rate and then arriving experimentally at why the programmers programmed it to be the way it is. So it's like in the end, and this is like one of the great things. It's like, and now you know why the default mutation rate is exactly what it is. And they're going, yeah.
I'm just curious where this 5,000 number comes from.
Who knows? Fucking sound.
Because that doesn't make it. I'm like, maybe you had a population.
Do you know
size
he even describes like Avita as like a LNCA thing? He goes like, yeah, when LNCA and them made Avita, and it's just like, bro, it's just such a glaring thing to people that know this stuff that says you have no idea what you're talking about.
Was the genesis that inspired Avita, and that came out of Chris Adami and
Charles Ofria, Brown and Ofria.
Titus Brown and Charles Ofria wrote Avita based off of that. And then they started working with Rich.
Rich Lenski is honestly just a famous scientist who uses it because he has an experimental evolution lab, right? Like I worked in a Lenski lab. He considers it an Avita lab, but he would not say. He would say he tries to do stuff to keep Avita funded and supported, but he would not ever take credit for developing it.
Yeah, but my understanding is Avita was already being built before.
100%, 100%. So I'm just saying, it's just another thing that makes it clear that Sal just doesn't know what he's talking about, right? It's just.
Yeah, I mean, I was there.
Doesn't even know the right people. Yeah, because you were around. Yeah,
I was hanging out with Charles because we were friends.
Yeah, absolutely.
But I know that he was working on this stuff when they were still at Stony Brook.
Yeah.
And I think they only met Rich at Caltech.
Yeah, and when they sent it to Rich, it was done.
Yeah. Well, I mean, done.
Or more.
None of this stuff's done.
Right. Yeah.
It worked.
Yeah, it worked. Yeah.
Yeah.
But yeah, dude, this has been super fun. Thanks so much for doing
Yeah.
this. And Monday at 1 if you don't pop in sooner.
Yeah. And yeah, I'll let you know how that stupid thing
Yeah,
goes and
yeah.
whether or not
Also, gauge the students for me. I'm interested to see, because I think so many students, right? This is the first time I've ever had a whiff of independence, right? And so they're Christian kids from Michigan, right? Let me tell you who my average student is. They're the same student. They're the same people that I see at church on Sunday morning when I play drums at evangelical church, right? They're just kids from Michigan who were raised Christian or whatever. Now they're at college. They want to go home and tell their mom that they're trying to stay connected to their faith or whatever, right? So maybe they find a little
right.
campus ministry or a little campus group, and now they're getting kind of pulled into this sort of organized holy war against science. And I just want you to see what you feel like. Do you feel like these kids are just getting caught up, or do you feel like there's some kids who are like they're real active? Blah, blah, blah. It'll just be kind of interesting to hear your perspective on that. That's all.
Right.
Yeah. All right, man. Thanks so much.
All right, later.
All right, appreciate you. I think I'll go back to the map view here, and yeah, we're chilling. I'll get my guy back over to where I should go. That was super fun. Where am I going? I am going back to the compound to be with my peeps. This actually feels like my real university shit, where it's like, of course I could work on campus, but you know, once I'm done with meetings and teaching for the day, I normally come to campus for meetings and teaching. I'm now done with teaching in my meetings, and I prefer to work in my own space. So yeah, this transported me back to my classroom because there are different spaces. We'll dip, dive, socialize on campus. Of course, I could just like pop out and change which space I'm in through Gather, but I like to make my little virtual commute. You know, it makes me feel the transitions in my day. Add meeting links in one click with via Gather Chrome extension. Yeah, I should check that out. All right, here we go. Back to my cubicle to chill. All right, gang. I don't know what happened with the stream earlier. I'm gonna actually end this stream because it was nice to just go over stuff with Cliff. I'm gonna end the stream. Then I'm gonna restart my computer. I'll try to go live through Restream again. And not through Restream, through Streamlabs again, because that's what I normally use. So I'll try Streamlabs again. If it works, we'll be good to go through Streamlabs. If it doesn't, I'll fire up Restream again. But I'm hoping that maybe a good reset or something will take care of whatever the heck is going on. So sorry to, had to interrupt the stream. You guys know a lot of times I like to just keep going for the day. I am done with my meetings and teaching. I want to do some Avita stuff. So what do I want to do? You guys are going to go over the introduction. I think I want to get in the Tower of Babel. So maybe when I fire back up, we'll jump in the Tower of Babel. If we get through that, we'll look at the Avita Ed stuff. We'll kind of get through our day here, see where we're at, and then we'll get into some fun times. Tonight, I know Joel said he wants to play some pool, so we'll play some pool. I definitely want to play some cards in my pinochle room, and I'm also up for gaming if there's stuff you guys want to get into. Holy shit, though. It's Wednesday. I think I was supposed to do a podcast yesterday. I forgot about, but I'm a fire up. Yeah, so that's fine. So I'm down to do some gaming tonight. I was just trying to make sure. I don't think I have anything on my schedule. I think there was something on my schedule last night, but yeah. So no worries. All right. So let me end the stream. Love you guys. Appreciate you. I can't really switch over to my camera because I'm going through Restream right now, and it's kind of different here. But yeah, let me. I'll be back in a few minutes. Appreciate you guys. What up, Nerdy? Good to see you. I'm glad you guys enjoyed this. Appreciate Cliff. And yeah, if you didn't get to check this one out from the beginning, maybe go ahead and do that later. I will see you guys in a few minutes. Please try to tune in when you see me go live again, because I want to jump into Tower of Babel, Rob Pennock's book, and I want to keep things moving so we get through a lot today. So I'll see you in a few minutes. Go ahead, take a potty break and grab some water or whatever, and we'll get right back to